Hi, I'm Viktor Lazzeri, CEO here at Barbieri Electronic. It's a great pleasure to speak to all of you today. Thank you for the invitation. Unfortunately, I cannot be live with you today. As you see, I'm remotely connected, and hopefully next time I will be able to join in person. I'm sure you already gathered great insights into the world of textile printing, digital textile printing. And I will speak now about accurate color measurement and color process control in digital textile printing. I will leave my contact details at the end of the presentation. And if you'd like, feel free to reach out to me for any questions you have. And without further ado, I will dive into my presentation now. Let's start with the presentation of accurate color measurement and color process control in digital textile printing. A few words about Barbieri. Barbieri Electronic is based in Italy. We're in the business for about 40 years, and we are market leaders in manufacturing spectrophotometers for color measurement in large format digital printing, flatbed printing, and a variety of specialty digitally printing. About the agenda, the presentation. So in the next roughly about 20 minutes, I'm talking about color challenges in digital textile printing. I will answer the question, why do colors variate? I talk about measurement technology in digital textile printing. And finally, about color process control in digital textile printing. Let's start with the definition of digital textile printing. It is any inkjet-based method of printing colorants directly or indirectly onto fabric. Here you see an example of a digital textile printer. Digital textile printing offers a variety of applications, printable materials, and printable colors, which leads to a major challenge: accurate and stable color results throughout different applications. Why is this challenging? Different applications or printer material ink combination require different production workflow and different pre and post treatments. And all of this results in different color gamuts or the amount of printable colors. Let's have a look at different gamut sizes in digital textile printing. All of these gamuts can only be captured if you measure colors with a spectrophotometer. On the top right, you see our Barbieri LFP-QB, our top of the line color spectrophotometer. Let's pick two technologies, pigment 4 colors and reactive 8 colors, and you will discover that the gamuts are different. Actually, on the right side, there's a bigger gamut, which means more colors are printable with reactive 8 colors, as example. Of course, this does not mean that one technology is better than the other. It just means different colors are possible. What does it mean to measure colors? You need an illumination, an object, and an observer. By illuminating the object, the observer gets the information about what color this object has. So actually, the light gets reflected back from the object into the observer, in that case, the human eye, which sees the color. Therefore, the color corresponds to the spectral product of these three components: illumination, object, and observer. Now let's have a look at spectrophotometers for digital printing. The slide you've seen before needs to be transferred into technology. And spectrophotometers are built according to ISO 13655 standard. The standard tells about the illumination, measurement condition, and the geometry. Then you need an object, in this case a printed color chart on a textile, and there is a spectral core or the observer. So same as before happens, but here with technology. It's important to understand that ISO 13655 defines the 45-0 geometry as standard geometry, as it gives a good approximation of the typical visual evaluation technique in graphic arts, including the effects of gloss and texture. This appearance measurement simulates how the human eye would see a sample. This is the inside of a spectrophotometer. You see the LED light sources illuminating homogeneous the media surface. Light gets reflected back to a spectral sensor. Accurate color measurements are fundamental to obtain the gamut and implement color process control. This leads to the question, how can you obtain accurate measurements on textiles? There are challenges to obtain accurate measurement results on textiles. You see here an example of a textile. First challenge is the structure of the textile. In fact, the surface is not even, but there are some structures on this material. Next thing is the distortion or the elasticity of the textile. As you see here, it's not straight and flat, but in fact, it has curves on it, so this is a challenge. With the challenge of the elasticity comes the next challenge. How can you mount such complicated materials to a dedicated sample holder so that you can measure accurately this textile material? And last but not least, fibers and dust of the textile could pollute a measurement device and falsify the measurement results. Let's look into solutions. How to handle different structures of textiles. The measurement aperture size of a spectrophotometer defines how much of a certain patch is seen and measured. As a general rule, the bigger the aperture, the more accurate the measurement will be. Here I have an example on a low resolution print. You see small size aperture, mid size, and a large aperture. So it's easy to see that with a small aperture, you capture green dot, blue dot, and with a large aperture, you capture much more information, capture a lot of blue dots, and also a little red dot. The same is valid for textiles or structured media. A small aperture might just hit the wrong spot where there is a hole in the material or something else. Mid-size aperture captures even more, and of course, most accurately, a large aperture. So the answer is, best results on textile and fabrics use an 8 mm aperture measurement device. I brought a video to explain how this is working. Let's have a look at it.
What's the real challenge when it comes to color measurement on different digitally printed materials? It is important to avoid wrong measurements caused by a minute measuring aperture. Materials with even surface and high-resolution prints can be measured with a small aperture so that many patches can fit on one single page for easier handling. Structured materials and surfaces require a larger aperture and larger patches to reach the highest level of accuracy. With our professional R&D department, we have been able to look closely at the obstacles and find the best solution. The Spectro LFP QB with its variable 2 to 8 mm aperture. By using a motor-driven optical zoom, the aperture size can be adapted automatically. This single instrument can be used to accurately measure a variety of different digitally printed materials to get the most accurate results every day. Thanks to Barbieri intelligent color measurement technology, precise color measurements will make you a top performer. When color quality counts, Barbieri.
The next challenge is how to handle distortion on textiles. Measuring on textiles is not easy because they are often not straightened, and finding the right spot to measure is challenging. The answer to this is that highest accuracy is given by an automated measurement process. Here you see the Spectro LFP QB Textile Edition with a sensing unit which is capable to capture the best possible spot to measure of each color patch. Let's have a look at a video which explains how this technology works.
Are precise color measurements on digitally printed textile materials important to you? Placing textiles on a sample holder can be difficult. As a result, the measured charts end up in a distorted position and the device measures in the wrong places. Our experienced R&D department has analyzed the problem and developed the right solution to solve these challenges. Precise navigation can be achieved with integrated vision technology. We have created the sensing unit. It detects patches and provides you with an automated measurement. Measuring distorted charts is no longer a problem because of this intelligent solution based on our vision technology. Thanks to Barbieri technology, precise color measurements make you a top performer. Intelligent measuring technology. When color quality counts. Barbieri.
The next challenge is how to handle mounting of textiles on a measurement device. Some textile material is translucent or slightly translucent. As you see in this example, placing the same material in front of a black background or white background, you already see differences. Therefore, measuring on this spot and that spot will result in different measurement values. So the answer is to use correct white backing, which is fundamental for consistent measurements. The ISO 13655 defines how a white backing should be. Here you see an example of a Barbieri electrostatic sample holder, which is conform to ISO 13655, which has a dedicated spectral curve and is valid as standardized white backing. Mounting of textiles to a sample holder for measurement is challenging due to the elasticity, which we've seen before. Therefore, please use always a dedicated textile sample holder. Here you see the electrostatic textile sample holder from Barbieri, which can be used with the Spectro LFP QB Textile Edition. The last challenge that I brought today is how to avoid pollution of the measurement device. Measuring textiles often leads to fibers entering optics, which can cause imprecise measurements. The answer is to use a measurement device with an integrated cleaning system, such as the air blowing system in the Spectro LFP QB Textile Edition, which blows out fibers and dust and keeps the instrument clean for most accurate measurements. Now we established how to get accurate color measurement data. And finally, we want to know how to perform color process control in digital textile printing. Let's start with the definition. Process control in digital printing is a series of actions which ensure output meets expectation by managing variables which can impact production. The main objective is to ensure accurate and consistent color reproduction by creating a tailored solution for each printer material and ink combination. But most importantly, we want to know if our printer is printing within the tolerances or outside the tolerances. And this leads to some question. How do we check if output meets expectation? How do we check if colors are printed accurate? And how do we check if colors are printed consistent? And the answer is by printing and measuring control strips. You see two examples here of a Barbieri DOC control strip. What are the steps to perform to obtain color process control? First, you start to calibrate or linearize your printer. After that, you want to create a profile for your material printer ink combination. When you have that, you can do a verification, which means you verify if you print, how you print against reference printing conditions, such as ISO, Gracol, Fogra, Textile RGB. This will tell you how accurate your printer prints the colors. After you establish that and are happy with the results, you start your production. And then finally, once in a while, regularly, you want to validate your print. And this by continuously printing and measuring control strips, which will tell you how consistent your printer prints the colors. A control strip is a set of patches including solid, secondary, and grayscale. Here you see a few examples, such as Fogra Media Wedge, Idealliance, and the Barbieri DOC control strip. What information comes with a control strip? Here you see an example. You find and will measure primary colors, secondary colors, grayscale, white point, and so on and so on. After you measured, of course, you want to evaluate your measurement data. Therefore, you need to measure your control strips and have a close look at the evaluation, such as our own Barbieri DOC report. You see a report can look like this, with all the information of every patch. You have added your reference before, and then you measure, and your measurement data will be compared to a reference. By doing this, on this evaluation report, you will see the uniformity, the color accuracy, and for example, the media. But most importantly, you will know if you print within tolerances or outside the tolerances. So to summarize this up, color process control in digital textile printing. Color will vary on different digital textile printers. Therefore, it is a challenge. Textile material causes challenges for measurement devices. A dedicated textile color measurement device ensures accurate spectral data. And color process control tells you about how accurate and consistent the colors are printed. So this was my presentation in a nutshell about color process control, digital textile printing. Here you find all my contact information. Feel free to reach out to me for any question you have. I leave my contacts here. And I hope you have a good rest of your day. And thank you for listening to this. And once again, feel free to reach out to us for any question you have. We are available and are happy to answer all of it. Thank you and have a good rest of your day.